Hey pre-algebra students, it's Miss Sandler. Sorry I'm not there today, but hopefully at this point in time you have checked last night's homework and finished the notes from yesterday. So if you have not done both those things, you need to stop this video and do those first. Today I'm just going to do a brief lesson with you about proportions and similar figures. So today, again, it's going to be very brief. It's going to be more of an introduction. So once you have this filled in, proportions and similar figures, into your table of contents, go ahead and turn to that next clean page. Okay, so proportions and similar figures. Alright, so first we're going to start with what a proportion is. We'll just write it here instead of our words worth knowing, but these are good definitions for you to know. A proportion, which you might be thinking back now to when we were making the tables and having to think if they were proportional or not. A proportion just shows that two ratios or rates are equivalent. And we know that we can write ratios and rates like fractions, so it's basically just saying that two fractions are equal. So a proportion is saying something like A over B is equal to C over D. Okay, it's literally just two equal fractions for the most part. Now, the next important thing to remember about proportions, if you had me in 6th grade, you've heard this before, I always said Mr. Fish, which is just a very informal way of remembering that we can multiply diagonally to get cross products. So our next vocab word is cross product. Cross products are just basically when you multiply your values that are diagonal from one another in a proportion or in a fraction. So we use cross products to solve a proportion if we have an unknown value. There's that. So let's say I had A over B is equal to C over something. I could multiply C times B equals A times question mark. And then now that we are so good at solving one-step equations, we could easily figure out that missing value. So that's when cross products are helpful. That'll make more sense once we start to set up our proportions. So then the next thing I want you to write down for your notes for today is we're going to get into similar figures. Yesterday we talked about congruent, we talked about the symbol we use for congruent. We talked about the fact that congruent means exactly the same. So now we're going to talk about similar. Charlie's here with us now, so in case he sits on the paper or something. All right, similar figures just mean, this is so blurry, sorry guys. Let's see if I can get this a little better. Isn't it blurry? I don't know. Sorry, hopefully you're doing okay there. Similar just means same shape. Okay? Same shape. So unlike congruent, where they were exactly the same shape, same size, everything, similar now is just when it's the same shape. Similar figures still, like yesterday with congruency, still have corresponding parts. Or remember how it was like the matching parts. So that's when we used the colors and we circled and we squared the different letters. So it's important to understand with similar figures that there are a few criteria that they must meet. So if two figures are similar, that means one, their corresponding angles are congruent, are exactly the same. Okay, so if one angle is 25 degrees, its corresponding angle on the other shape must be 25 degrees. And the other piece that makes something similar, the measures of their corresponding sides are proportional, and we're going to talk about what this looks like. Okay, so here's an example of what this means. Let's say we had triangle ABC, and I'm telling you that triangle ABC is similar, notice how we show similar, to triangle XYZ. So just like yesterday when we were talking about congruent figures, these letters need to match up. So A goes with X. B goes with or corresponds with Y. C corresponds with Z. Okay, so that's the first important part to understand. Angle A must be the same as angle X. And again, hopefully, whatever I'm writing down, you are expected to as well. Angle B is congruent, is exactly the same as angle Y, because remember, the corresponding angles are congruent. Angle C is exactly the same as congruent to angle Z. Now, the next part that makes this different than congruent, this now tells me that their sides, so let's actually draw these triangles so we can see it better, their sides are going to be proportional. And we'll talk about what that means. So, let's move this up. If we have triangle, whatever, A, B, C, and we have triangle X, Y, Z, and I know that A must be congruent to X, B must be congruent to Y, and C must be congruent to Z, Remember, we just use those tick marks and those little angle marks. So then now I know that A to B must be proportional to XY. So I'm going to say A over B should be the same, should be proportional to X over Y. Just like B over C should be the same proportion to Y over Z, which is the equal to, is the same as A over C should be the same exact proportion as X to Z. Sorry about that. Okay, I know this is confusing because it's new, but if you have these in your notes, this is really, really important. Okay, so let's take a look at what this means. I want to start with a basic one. Let's do rectangles, and then we're going to be done. We'll do more of this tomorrow. I just wanted to give you a little glimpse. Let's say we have rectangles, rectangle H, J, K, L, and we want to figure out if it's similar to rectangle M, N, P, Q. Okay, so I'm going to draw a rectangle H, J, K, L, and I know that rectangles have right corners. Remember that. And let's draw rectangle M, N, P, Q. Again, it's a rectangle. I know it has right corners. So we can just tell, I mean, not that we would ever just look at them and determine, but these are different sizes, so I know they're not congruent. But again, I'm trying to figure out if they're similar, if they meet this criteria. I'm also told that this side length is 7, and this is 3. This is 6, and this is 10. So, I know so far that all of my angles are congruent, right? Because they're all right angles. So that part of the criteria is checked out for them to be similar. Now I need to determine if their sides are proportional. So I'm going to look at my first two sides, HJ and MN. Well, HJ is 7, and it corresponds to MN, which is 10. If I put 7 over 10 into my calculator, 7 out of 10 is 70%, or 0.7. I tried. Now I'm going to continue. JK corresponds with MP. Remember, the order matters. So my second two letters, my second two letters. Well, JK is 3, NP is 6. When I simplify that, I know that that's 1/2, or 0.5. Right away, I can already determine these are not similar because their proportions are not equal. 0.7 is not equal to 0.5 when I simplified these fractions. They're not equal. Therefore, it says the measures of their corresponding sides are proportional. Since these are not, I can say right here, these rectangles are not similar. Either all of the sides would have had to come out to 7 over 10, or all of the sides would have had to come out to 3 over 6, or half. Okay, so once I see that 2 of the sides do not correspond, I can be done. I can say not similar. Okay, so that's your preview for today. We'll continue working on this tomorrow and Thursday. Now that you've finished your notes, I'd like you to work on IXL. Again, if you weren't here yesterday, extra green sheets are in the Monday folder. I'd like you to work on the Congruent and similar skills, the top 3 skills on your sheet. Okay, that is due Friday. Email me if you have any questions. Bye, guys.